attention to the objective for today. We want to discuss what polynomials are a little bit and make sure we understand that before we go into working with them. So the first thing we're doing is filling out this Google form. After you watch the video, you're supposed to be able to fill this out. So what are polynomial functions? You have the standard form that he went over in the video. Your leading coefficient goes with the highest powered x. Like if the highest power is 5, then the degree of the polynomial is 5. And you have some names here. Some constant is if you have your x is not showing linear as a power of 1, 2, 3, and quartic is 4. So those are the ones you're responsible to be familiar with. So I have a question for you. If you look at the quartic and you look at the very end, there's your constant value, like -1 or +5 or whatever. So if we wrote x to a power beside the constant term, what would it look like? Would it just be an x, or would it be a 1, or an x to the 0, or a 0? What do you think would go there? If you look at the pattern, quartic is a degree of 4. So you have x to the 4th, x cubed, x squared, x without a power, so that would be 1. So what would go here? X to the, what power would it have to be? 0. It has to be x to the 0. So the reason you don't see x to the 0 is because last lesson, remember when we did exponents, anything to the 0 power equals 1. So that's why you never see x to the 0 there, because it's 1, and so we don't write it. We don't have to, so we don't want to do that extra writing when we don't have to. Which letter of the alphabet do we use to denote the degree of the polynomial? X, Y, P of X, or N? N is correct. So instead of having to write out the word degree, you can just put like n equals 5 instead of the degree of the polynomial is 5. See how much writing that saves you? Okay, identifying polynomial functions. There's some examples. Your degrees, they have to be whole numbers like 0, 1, 2, 3, 4, 5, and so on. Your coefficients are real numbers, and you cannot have division. Like you can't put 12 divided by x, because that means that x would be to the power of -1, and we don't have negative powers. So you can't have division in a polynomial. All right, so monitoring progress. Decide whether the function is a polynomial function. If so, write it in standard form and state its degree, type, and leading coefficient. So if it's not a polynomial, then just put not a polynomial, and you don't have to do all that. But the first one is a polynomial. So the answer to number 1, you have to put it in order. And if you're using your keyboard there, you probably don't have a power button, so you don't have the equation editor. So you'll just have to use that upside down B for your power. So the highest power you see in number 1 is the 2. You want to start with -1.6 x to the power of 2. And then next you see the linear term, which is -5x. And then you see the constant, which is +7. Okay, so now it's in order in standard form. State its degree. So if your highest power is 2, you have a quadratic, and it's n equals 2. And then after that, the type, and you want to go to the table. So if your degree is 2, that's your quadratics, of course. So your type is quadratic. You can get that from the table. And then lastly, there's something else you have to do. The leading coefficient. The leading coefficient is front of the highest degree x value, so x squared is the highest, so your leading coefficient is -1.6. And yes, if it is negative, you do want to put that as negative, because we are talking about a negative term. I mean, values can be negative, so we don't just put 1.6. We're not talking about like vertical stretch or anything like that. We're talking about what number is it. Any real number can be a coefficient. Okay, so you'll have to finish that. The next concept we want to talk about that has to do with characteristics of polynomials that we want to discuss before we do add, subtract, and multiply is the end behavior of polynomial functions. So when you're looking at the graphs, you know what type of polynomial you're looking at. Okay, if your degree is odd and the leading coefficient is positive, it's going to be rising. Well, not in the middle, but the ends would be rising. So they'll go in opposite directions. If your leading coefficient is negative and the degree is odd, like 3 or 5 or 7, then the parent function is strictly decreasing. So you're going to be decreasing, not in the middle necessarily. But as far as your ends go, they go in opposite directions. And then if your leading coefficient is positive, like positive 5 or positive whatever, x squared, we always did quadratics open up and down. The arrows point the same way. If your leading coefficient is positive, it opens up and your degree is even, like 2, 4, 6, 8. If your degree is even but the leading coefficient has a negative sign, then they both point down as far as the ends go. Okay, summarize the end behavior. So you'll have to discuss what we just talked about there, about how odd, if you have an odd degree, your ends go in the opposite directions, and even they both point the same way. So you'll have to talk about that. And you can even say more. Questions about the end behavior. In exercises 17 through 20, describe the end behavior of the graph of the function. So problem 17, you have negative 5 x to the 4th. That's all we need to look at for the end behavior. We have an even degree, but our coefficient is negative, so they will both be pointing down. So here I gave you some choices. B, both ends point downward. We want to choose B. And then you can do 18, 19, and 20. Just put the letter from 17. You don't have to write the whole thing. In 21 and 22, you have to describe the degree and the leading coefficient. So is it odd or even? And is your leading coefficient positive or negative? So you'll have to write that out or type it out in 21 and 22. And then find the sum of the polynomials. Okay, now we're to adding. Find the sum is just combining like terms. So I don't know if you're even going to have to write this problem down. Just look across the problem and look for the same degree. Those are the ones you add together. Combining, it's literally combining like terms. 3x squared and negative 2x squared, you get 1x squared. So you'll start with the highest power term. So that would be x squared. And then next you have linear terms. Some of the terms can be missing. If it's missing, just write what you have. You're combining it with 0 then. So anyway, we have linear in both of these two polynomials. We have 4x and we have negative 3x. So when you combine that, you get 1x or x. And then you're combining negative 1 and 2 together, and that makes positive 1. So plus 1. All right, and then you can finish those. And like I said, like in number 5, you see how you have 12x to the 5th, but the other polynomial doesn't have a fifth term. It just has a degree of 4. So you'll just start by putting 12x to the 5th. It's like adding it to 0x to the 5th. So you still have to, write it. It just isn't added to anything more. All right, find the difference is the same thing as adding, except you have to distribute that negative sign. Okay, when you have a negative, you have like a 1 in front of the parentheses. So negative 1 is the same thing as add negative 1. Minus 1 and add negative 1 are the same thing. So you have to distribute that negative sign. To drop the parentheses, all of these signs must change. And then you just add. So we're practicing it because a lot of students, they'll just do like the first term and then they'll forget the others, or they don't know their integer addition rules, and so they mess up there. So we do have to practice this. It's important that you know your integer rules. Okay, so here we would have 3x cubed minus 5x cubed. That would give you negative 2x cubed. Okay, then we have minus 2x squared and plus, that's actually minus 12x squared. So that would be a total of negative 14x squared. So minus 14x squared. Our linear term here is 4x minus minus, so that would be plus 3x. So that's a total of positive 7x. So you see, if you don't know your integer rules, this will be hard for you. Here we have minus 8 minus negative 4 would be plus 4. Negative 8 plus 4 would be a total of negative 4. Okay, and so that's just how you are going to do those problems right there. Make sure when you draw the parentheses, each of the terms has switched signs, and then you can add them together. And then put your name and my name, Kauscher, Kaucher. I hope you all know my name by now. It's this one, Kaucher. And then your period number, and that would be a great help because some other students are filling this out, so make sure you put that information there. Like from different classes, from substitutes and other teachers, so just make sure you put the teacher name so I can sort the spreadsheet. Okay, so there's some problems you have to do to share with other students. See, some students have answered, and then you'll have to compare. And if you have any questions, you can also reply. Like here, Eddie did his problems. If you want to talk to Eddie, you just press reply. Like if you want to ask him a question or you disagree with something, or you want to say, I don't think you're right, you know, or yeah, you did a good job. I mean, either way. Okay. Here, you're finding the error. Anybody see what it is? I like to do these. Anyone see what the error is there? You have x squared minus 3x plus 4 minus x cubed. Then it says plus 7x. What did they forget to do? And minus 2. See what happened? They just used the minus sign with the first term. They didn't distribute it. It should have been minus x cubed minus 7x plus 2. So you'll get the wrong answer if you don't do that. So that's your error there. So you're going to have to write something about that. Okay, when you multiply polynomials, you're distributing. You're distributing and distributing. That's what you're doing. And then so after you distribute, you combine like terms. So I just wanted to point out here, this is a monomial, one term times a trinomial. Those are the easy ones. You just take the monomial times all three and you're done. So those are really easy. I just want to show you his method at the end, since there's different methods. When you have more terms, the harder ones, there's different methods. So I want to show you his method.
Times negative 2x plus negative 4x times negative 2x, and on and on and on. But this method that I'm about to show you, called the table method, makes the whole process way more organized. It's easier on the eyes, and it's easier for you to do your math correctly, to keep track of all your details. So first we'll organize it. So here we have 5x squared. Let's draw a line. Minus 4x. Draw another line. Then positive 6. Here we go. And then here we have negative 2x. And then positive 3. So here we have our two polynomials. And now, in each square, we'll do our multiplication. So here we have negative 2x times 5x squared, which that is negative 10 x cubed.
Okay, the way you get x cubed is you have the same base and you're multiplying, so you add your exponents, 2 plus 1. That's how you get 3.
Using our function rules and our exponent rules, the negative 2x times negative 4x, that ends up being positive 8x squared. Negative 2x times 6.
This is a new teacher this year.
So we do the same in the second row. So we have 3
I think he's doing a good
times
job.
5x squared. So that's 15x squared. 3 times negative 4x. That's negative 12x. Then 3 times 6 is 18.
Okay.
So there we go.
So then you have your terms. So what you have to do is just find like terms and add them together and write your answer down. So you would write negative 10x cubed. You would add these two together and write 23x squared. Then you would add these two together and you would record negative 24x because you now have negative 24x's, and then plus 18, and that would be it. Okay, so there's a method you can use. There's 2 other ways you can do it. You can write it the whole way across horizontally and then just look through it and find like terms. Or you can do the vertical method, which I'll show you, and that's where you stack it each time you multiply under the one above it, and you make sure that you stack under the same powers. So that's another method. I want you to look at this error. It's really important that you understand what is wrong with this picture. When you're supposed to do 2x minus 7 cubed, it means you write 2x minus 7 3 times. It's a lot of work. It's not an easy peasy problem like this, where you just kind of distribute, because you have a minus sign here in the middle, not multiplication. When you put the 3 with both terms, it's if you have multiplication in here where you can split it up like that, like this. This is totally incorrect, very, very incorrect. The answer is nothing like that. You're supposed to write 2x minus 7 in parentheses 3 times and multiply it all out. And there's some other methods too, but you will not get the right answer if you try to do some kind of rule with exponents that's incorrect. Another method is Pascal's triangle. So the problem we just spoke about is cubed. That's the 3rd row. You had something plus or minus something cubed. If you use Pascal's triangle, it has a pattern. It shows you how you could do this without actually multiplying. You just use this pattern. Pascal's triangle is built by putting ones along both sides, and then you add these numbers together. 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3. Right here you see 1 plus 3 is 4, 3 plus 3 is 6, you see? So you can build this triangle without really having a lot of memory issues. I mean, it's not hard to remember. And so we would be in the 3rd row for the problem that was just done, 1, 3, 3, 1. Those are the coefficients you always put in the front. And then you do a cubed. See how this is decreasing? 3, 2, 1, 0. And then for b, you start with b to the 0, b to the 1, b squared, b cubed. It's a very easy pattern to remember. So you may want to try to use Pascal's triangle for the perfect, powers. Most powers aren't perfect though, so, you have to do a lot of distribution with multiplying. You can't get away from all of it. Okay, here's some practice problems. These are teeny tiny. First thing I want to point out for multiplying polynomials is that there is some vocabulary involved. Monomial is when you have one term. Binomial is 2 terms. And you can multiply, for example, in problem 4, a monomial times something with 4 terms. 4 terms is just called a polynomial with 4 terms. We don't have a special name for it. And here you have 3 terms. So that's a trinomial times 3 terms. That's a trinomial. Trinomial times a trinomial. Or the problem Mr. Aguiniagua, I'm not sure how you say his name, something like that. Aguiniagua was showing you had a binomial times a trinomial. I don't think we have any of those right here. No. So we're going to go to the whiteboard, and like the problem he did, the one where you have a monomial times something, those are the really easy problems. I think you could probably even do those without my help. I had the problems larger. I can't see those little problems very well. And they disappeared. So let me see if I can find them. Oh, wait. It won't take me too long, I promise. I had it up there and it disappeared. Here, it's this. Here they're bigger. So we have 2x squared times 2x cubed minus 2x plus 3x minus 5. Okay, so we have 2x squared times, oops, we don't need that anymore, do we? We already did that. 2x cubed minus x squared plus 3x minus 5. And you do have to do these problems, so you might want to get started. Okay, so like I said, these are really easy. In order to distribute and drop the parentheses, you just take the 2x squared times each term. So 2x squared times 2x cubed, 2 times 2 is 4. As far as the power for the x, since you have the same base, you add 2 plus 3 is 5. Okay, so then you're going to take 2x squared times negative x squared. That's going to be a negative 2, and 2 plus 2 is 4, so negative 2x to the 4th for the power. And then you're going to take 2x squared times 3x. 2 times 3 is 6. And then you have a 2 plus a 1, so that would be x cubed. And then you're going to take 2x squared times negative 5. So, of course, that would be negative 10 for the numbers. That got kind of weird looking. Let's not do that. Let's write it pretty. As pretty as you can get with the whiteboard. It's not a very pretty thing. Okay, so that 2x squared times negative 5 would be negative 10x squared. So that's just your answer. There's nothing more to it. Those are the easy ones where you have a monomial times a polynomial. The ones that are harder are like the one he was doing with a binomial times a trinomial, but we're actually going to do a trinomial times a trinomial. Here we have, hard to see, x to the 4th minus 10x squared plus 25. And we're going to take that times another trinomial. And we're going to do two different methods. We're going to do the method that Mr. Aguinagua or something like that taught you with the chart thing. And this is 3x squared minus 6x minus 1. Let me just make sure everybody's in the meeting that wanted to be in here. Okay, no one's waiting. Okay. All right, so if you do the chart, all that you're going to do is make yourself a chart. You have to make it yourself, so of course that takes some time. Not that much time. So you're going to write the one polynomial along the top and the other one along the side. Okay, now you're going to multiply in here in the box. Trying to make it neater, but it didn't work out the way I thought. So you're going to take 3x squared times x to the 4th. So that would be 3. 2 plus 4 is 6. So 3x to the 6th. 3x squared times negative 10x squared. Some of you will really like this method and some of you will not. So 2 plus 2 is 4, and then you have 3x squared times negative 25 is negative 75 x squared. Okay, here you have negative 6. 1 and 4 is 5, so that would be negative 6x to the 5th. Here you have 60. 1 and 2 is 3, so 60x cubed. And then that would be negative 30, 12, and 3 would be positive, though. Positive. This is negative times negative. It'd be positive 150x. Okay, negative 1 times x to the 4th gives you negative x to the 4th. And then you have negative 1 times negative 10x cubed, so that's positive 10x cubed. And you have negative 1 times negative 25 gives you 25. Okay, so then you're just going to find your terms. There you have a 6, and I think that's the only one that have the same power and combine like terms. Okay, so then you have 5 here, so minus 6x to the 5th. Okay, now we're at 4, and they're not necessarily going to be any that are 4, but we do have some that are 4. We have negative 30 and negative 1, so that would be negative 31x to the 4th. Okay, then you go to 3. So you have 60x cubed and 10x cubed. That makes a total of 70x cubed. Okay, then squared, you have negative 75. Is that it? Negative 75x squared. And then you just have a power of 1, just the 150x. See how many terms there are here on this problem? And then you have plus 25. I guess I can move this over if we wanted it to be there beside that. And we'll put it beside the 150x. Okay, so that's one method of organizing it. Only thing I would suggest, since these are kind of all over the place, is you might want to, as you use them, just to make sure you get them all, I might want to cross them off. There we have that. And the third, we have this one and this one. So it's easier to see that you actually used them all, which we did. Okay, so that's one way to do that problem. The other way to do the problem is to just write all, when you multiply, just write it all, keep going all the way across, and then just look through your list and add them together. And again, if you do it that way, you might want to underline or cross off your terms as you use them. Not because it makes 0, but just to keep track of which ones you already used to make sure you don't miss any. So you can do it that way. It's almost the same as doing it this way. And then the other way I want to show you is to line it up vertically instead of horizontally. So this is actually my favorite method. When you do this, you're going to take the x to the 4th times all 3 terms. Then you're going to take your next term times all 3 terms. And then you're going to take the negative 25 times all 3 terms. Okay, so x to the 4th times 3x squared. That gives you 3x to the 4 plus 2 is 6. X to the 4th times negative 6x, that gives you minus 6x to the 5th. X to the 4th times negative 1 gives you minus x to the 4th. Okay, so now you're going to do your negative 10x squared times all 3 of these. So negative 10x times 3x squared, you get negative 30x to the 4th. So you put that under the other x to the 4th term. So that way you're going to add going down this way. Then you take your negative 10x squared times your 6x, and you get 60x cubed. Okay, then you take your negative 10x times your negative 1, And that gives you positive 10x squared. Okay, and then you still have negative 25 times 3x squared. So negative 25 times 3x squared would be negative 75x squared. So we're going to put that with the x squared column. Then you have negative 25 times negative 6x squared. That's our plus 150x. Then you have negative 25 times negative 1 would be plus 25. So sometimes you're missing some of these terms, and this may be shifted over. You could have a cube term, or you may have a fourth term or fifth term or whatever. You just have to put it under the same power, and then you just add going down this way. This is the way I like to do the problem the best, but I often just write it the whole way across and look for them. Here you're adding negative 1 and negative 30 to get a total of negative 31x to the fourth. Then you have 60x cubed. Here are your squares. So you have plus 10x squared minus 65x squared. That doesn't look familiar. Negative 10 times negative 1. You had 25, negative 75. Yeah, I think that's right. Maybe we did something wrong in the other one. That doesn't look familiar to me at all. And 150x and then plus 25. Let's see what we get last time. Did we get negative 65x squared? Oh, I guess I erased it. Oh well. Anyway, you're supposed to come out with the correct answer. Okay. Let's see what else do we see on this paper. Okay, we have a cube here. We have 2y minus 1 cubed. So let's talk about that a little bit. 2y minus 1 cubed. Like I said, that means you're supposed to write it 3 times and multiply it times itself 3 times. You're not supposed to distribute that cube to each of those terms. That will be exactly wrong. So after you write this 3 times, what you can do, we'll try Pascal's triangle then, but first let's multiply it out because you might not remember how to do Pascal's triangle at the last minute. So you might have to just multiply it out. Okay, so what you do is you write that first binomial, and then you take these two binomials and do the FOIL or double distribution. You take the 2y times each of these two terms. 2y times 2y is 4y squared. 2y times negative 1 is negative 2y. And then you'll see when you take the negative 1 times negative 2y, that is duplicated because these are very perfect. And negative 1 times negative 1 is plus 1. So this here in the middle is going to be duplicated. Let me just change that to negative 4y so we don't have to rewrite the whole thing. Okay, then you have to do it all again. You have to take 2y times 4y squared, which is 8y cubed. And you have to take 2y times negative 4y, that's negative 8y squared. And you have to take 2y times 1, which is plus 2y. Okay, now you're going to take negative 1 times all 3 terms. So we have negative 1 times 4y is negative 4y squared. We have negative 1 times negative 4y, which is 4y. Negative 1 times positive 1, which is negative 1. You're going to add these together. Okay, so that gives you 8y cubed. And then you add the squareds together, you get minus 12y squared. your y terms together gives you 6y, and then minus 1. So probably doesn't look quite like you thought it was going to look, because when you look in the Pascal's triangle, it had, I think it had 1, 3, 3, 1, didn't it? So let's go back and look at the Pascal's triangle for when you have something that's perfectly cubed. Okay, that's this row. Third row is the cube. So you have 1, 3, 3, 1. So how did we get those other numbers? Okay, well, let's do this. A cubed goes to a squared, goes to a, goes to a to the nothing. So you don't see it. B0, B1, B2, B cubed. So I don't think that's that difficult. Let's just move this over slightly and see if we can get the same answer using Pascal's triangle. So we have 1, 3, 3, 1 as our pattern, and then we had a cubed, b to the 0. Then we reduce that to 1 and have a squared, but we have b to the 1. Reduce the a by 1 power, put the b up by 1 power. And then, of course, b goes up where a goes down, so a disappears. So this is the pattern we want to have. In this problem, our a is 2y, and our b is -1. So all we have to do is fit those in there, and that should give us our same answer that we got down here. So let's see if it actually works. I hate when that scribbles. All right, so for our first term, 1a cubed. So that would be 1 times 2y cubed. Well, 2y cubed times 1 is just 2y cubed. Then we're going to take 3 times a, so 3 times 2y, times b, so times -1. Then we're going to take 3 times a, so 3 times 2y, times b squared. And -1 squared is just 1, so we don't really have to write that. And then our last term we're going to get by cubing the b terms, so -1 cubed. Okay, so that's 2 cubed is 8, y cubed is y cubed. Notice that's the same thing. Here we have -1 times 3 times 2, that's -6y. No, wait. We were supposed to square the a. I forgot to square it, didn't I? Yeah. So that's 3 times 4 is 12 times -1 is -12. And then the y here is squared. Yeah. Okay, and then here we have 6y times 1 is just positive 6y. And then we have -1 cubed. -1 times -1 times -1 is -1. So that would just be -1. So yes, we got exactly the same answer. So I don't know which way was easier. I think it depends on if you actually remember the pattern for Pascal's triangle. If you practice it a little bit, and I have some problems for you to practice, then you might remember it. So if you look at the practice for multiplying here at the bottom, these you're both supposed to do with Pascal's triangle, 4t minus 2 to the 4th, t plus 6 to the 5th. Use the pattern and see what you get. Obviously, you're not going to want to do g plus 6 to the 5th. You'd have to write it out 5 times. I mean, you can check it if you want. I think it'd be better to just check with somebody else and see if they have the same thing. Be easier. Okay, last but not least, we have special patterns of polynomial products. You do have to know the first 3. You must know them because when you factor, you go backwards and you have to know what you're looking at. You have to get accustomed to what you're looking at. The first special product is where you have an a plus b times an a minus b, and you get a squared minus b squared. Such as if you have x plus 3 times x minus 3. They have to look the same but with a plus and minus sign. Instead of getting 3 terms over here, see below how you have 3 terms usually? When you take a binomial times a binomial, you get a trinomial. This is the only situation where you get 2 terms, because the middle would be plus 3x and minus 3x, and that makes 0. So what you get is the x squared minus the 3 squared, so x squared minus 9. Okay, that's the difference of 2 squares. That's what it's called. Then you have your special perfect squares, and they make perfect square trinomials, is what they're called. So if you have a situation where you have plus in the middle, like y plus 4 squared times y plus 4 squared, you can follow this pattern and you don't have to multiply it all out. That's to square the first term, then take 2 times these two. 2 times 4 is 8 times y, so plus 8y, and then square the 4 is 16. You really should know this one. The first 3 you should know. You need to learn them. Okay, here you take 2t squared, so that would be 4t squared. And 2 times negative 5 is negative 10 times 2 is negative 20t, and then you square the negative 5. Notice how this is plus here. Plus and plus is when you take positive 4 times positive 4, you get positive 16. When you take negative 5 times negative 5, you get positive 25. So you'll either have a plus sign there if this is plus, or a minus plus if this is minus. And then these, I wouldn't bother with these too much. Your cube of binomial, they just write it out and want you to memorize it, but it's 1, 3, 3, 1. It's from Pascal's triangle. You just remember that. It's the same thing. So I would prefer if you remember the Pascal's triangle. The same, very same thing. So remember that, row 3. All right, so we're going to try to practice this until we only have like 5 minutes, don't we? Yeah. So we'll just kind of try to do it on our head. X minus 4 times x plus 4, what do you get when you multiply that? Griffith, what do you think? What do you get? X minus 4, x plus 4. The first term squared minus the other term squared. What does that give you? Yeah, the x squared minus the 4 squared. X squared minus 16. Okay, are you with me, Griffith? I can't tell if you can hear me. So your answer for number 1 should be x squared minus 16. That's it. Okay, for number 2, you're doing the same thing. A plus and minus the same thing. So you're going to square the 2x, the whole thing though. So it'll be 4x squared, square the 5. So it will be 4x squared minus 25. This is always minus. It's always the difference of the 2 squares. That's what it's called. So we can't do the sum of 2 squares to factor to go backwards because it's imaginary. You're trying to take a negative square root, so that's why it's just difference of two squares. Okay, here's the perfect squares. Perfect cube, we probably won't have time to do. You can do the Pascal's thing to do the perfect cube. Okay, let's look at 6x minus 3 squared. Okay, it's important that you know how to do this. So the perfect square trinomial, you can multiply it all out. You'll get the same thing. You square the first term to get 36x squared. Since this is a minus sign, you'll have a minus and a plus. You take 2 times 3 is 6 times 6 is 36x. This is just a coincidence that they're both 36. They're usually not. Negative 3 times negative 3 is plus 9. So that's what you get. You'll get the same thing if you take x minus 3 times x minus 3, or if you use Pascal's triangle. Same thing. So if you forget how to do the pattern, then just multiply it out. It doesn't take that much longer. And 2a plus 5 squared. Okay, this time you have addition. 2a plus 5 squared. Anyone want to tell me what you get using the pattern? Anyone know? Eric, do you know? Okay, well, first of all, if you have a minus sign here, you get minus plus. If you have a plus sign here, what signs do you get? Plus, plus. Okay, so square the 2a. What's 2a squared? The whole thing squared. Right, 4a squared. And then take 2 times this times this. So in other words, 2 times 5 times 2a. That's going to be your middle term. So 2 times 5 is 10. 10 times 2a would be 20a. And then just square the 5. We all know that's 25, right? Okay, that's the same thing you would get if you take your 2a plus 5. 2a plus 5. And some teachers just make you do that because they want to make sure that you can actually do that before you learn a trick to it, you know, a special pattern that lets you save time. But the reason I want you to be familiar with a special pattern is because from here, you might have to go backwards. You have to be familiar with this for something else. So that's why I want you to be familiar with it. So 2a times 2a is 4a squared. You take 2a times 5 is 10a if you multiply it out. And then you take 5 times 2a, that's 10a. See how you get the 20a in the middle? And then you take the 5 times the 5 is 25. So see, exactly the same thing. So it's not that much shorter to do it using the pattern. So if you forget it, just multiply it out. It's just that students want to just put 4a squared plus 25, and that's completely wrong. You have a middle term. Okay, it's time to go. So if you don't have any questions, you're going to have to go to your next class so you're not late.